What's up, math scholars? Thanks for joining us. A lot of people are gone today on field trips, choir trips, baseball trips, tennis trips. So there'll be a lot of people watching the video, I hope. We kind of have a longer lesson today, but it is easy, so that's good. All right, we're going to start with this warm-up. Who's excited about being Friday? Yeah, Friday, Friday, Friday. All right, so we have a lot of options as far as how to start. I personally would start with finding theta. So raise your hand if you have found theta. Spencer? Never mind. Lexi found theta. How many? 60 is incorrect. Carly? 51. Could you tell us how you got 51? Right. There's 180 degrees in every triangle, so she subtracted her way around to get 51. Oh, just she saw it wrong. Okay. Now, you have a choice. You can either start with solving A or start with solving B, and then you can choose to use the 51 or you can choose to use the 39. So there's so many options. Can I just have somebody tell me what you decide to do? Spencer? Okay, so he used the 39 to figure out A. Did you use what? So 39 equals A over 12. Sounds like he said he multiplied the 12 over to the other side. Can you tell me what you got for your answer?
I got 7.5.
Perfect. Now, once you have that 7.55, you could finish off with the Pythagorean theorem, or you could just use another trig ratio. So, can I have a different person tell me how they got B? Oh, Jessie? So she cosines the 39 and set that equal to B over 12. Multiplied by your 12. And what'd you get for B, Jessie? 9.3? Oh, no. All right, we are recording. We are doing 9-2 today. We're going to start on our journey with the unit circle, talking about how it's used, labeling it with degrees and radians. Okay, everybody has a unit circle in front of them. If you don't have a unit circle in front of you because you're at home, you can always Google blank unit circle and print one. Or I maybe gave you one had I known you were going to be absent today. Or maybe even go to the end of the notes and you can find one on there, in the slides. Or maybe print a slide from the notes. That would work. There's so many options. All right. So, voila. There's a circle. And I'm going to talk about how this works. With your unit circle, you're going to have an initial side. This is where every single spinner will start. So think about this as a spinner, spinning around counterclockwise. So your spinner will always start here at 0 degrees. As it spins, you start adding degrees. So 30 degrees, 45 degrees, 60 degrees. Bam, I'm now at 90. 120, 135. Bam, I'm down here at 180. Keep spinning, keep spinning, keep spinning. This is where 270 is. Keep spinning, keep spinning, keep spinning. 360. So basically 0 and 360 are located at the exact same location. Does that make sense? So why don't you go ahead and grab your unit circle. I'm going to show you where to kind of put the first part of the information. See these like little tiny dots? Those are degree symbols. So right here at this initial side, you're going to put 0 degrees in the first blank. And you're going to put 360 degrees in that second blank. Make sense? So this would be 0 degrees and 360 degrees. Now there is a coordinate there. Leave that blank. We'll get to that later in today's lesson. Leave the coordinate blank. Go up here to 90 degrees, put 90 degrees in that blank. Go ahead over to here, put 180 degrees in that blank. And then go down to here and put 270 degrees on that blank. Alright, so I'm going to walk over to the computer. You might not be able to hear me talking into the microphone that well to show my class how this spinner will work. So this pink line is a spinner. And it spins around. And it can spin around as many times as you want it to spin around, okay? So help me out. What would be here? 90, 180, 270, 360, 450. 540. So 500 would probably live somewhere in here, right? So I'm going to go ahead and label that 500. I went right by 240. I should have stopped and labeled 240. 500 would probably be around here. 240 probably would be around here. We bypassed that. I forgot to write it down. Yes, question? So the student question was, if we're going to do a positive spin, we're going to go counterclockwise? And I said, absolutely. So he was looking ahead because choice C over here, let me go back to my computer. Choice C, let me go back to my terminal position, or my initial position. Choice C says go negative 50 degrees. Guess what? Clockwise would be a negative spin. So negative 50 degrees would probably be about there. Make sense? So make you jot that down on your unit circle. Make a big, huge, maybe pink or yellow, maybe you have a highlighter. That this is where you always start, the initial position. And then you go counterclockwise for positive spins and clockwise for negative spins. Okay, so negative 50 would probably live right about here. Who would live right here, by the way? Who would live here? Negative 90. Who would live here? Negative who? Negative 180. And who would live here? Negative who? Negative 270. So 90 and negative 270 are the same spot. Isn't that cool? It's in the video. So this kind of discusses what I was talking about a second ago, but 500 lived about here, right? It says that 500 and 140 live in the same exact spot, and they are called coterminal because they their terminal sides would be in the same exact position. So basically, you can find angles that are coterminal by just adding or subtracting 360 numerous times. So I'm just going to make up a number, 760. Let's find where 760 would live by adding and subtracting 360 times. So what's 760 minus 360? I still don't know where that is. Let's subtract 360 again. 40. So, oh my gosh, it would live right here about at 40 degrees. So 760, 400, and 30 would all be coterminal, and they would all live in the same exact spot on the unit circle. 40. Oh, 40. Yeah, my bad. Thank you. She did. She saved the day. She totally gets a ticket. There we go. Sorry about that on the video. I apologize on the video a lot this week, huh? It says find one positive angle and one negative angle. That would be coterminal with negative 45. And then we'll do 395 next. So here's where my initial starting position is for my spinner. Let's go ahead and spin negative 45 degrees. Can you point with your finger where I'd be living at after a negative 45 spin? We are going to go this way, and most people are pointing down here. So that's good. Negative 45 is here. So to find somebody that's coterminal, what would I do in my calculator? Add a 360. So 315 would be in the same exact position. Questions on that? Let's go ahead and do a 395 degree spin. So this is where I'm going to start. I'm now going to go positive 390. Could you point to where I would live? This one's kind of weird. So this would be 90, 180, 270, 360. We'd still have to keep going. So 395 would probably be about here. If you subtract 360, you get 35. And let's go ahead and subtract another 360 because they mentioned finding negative coterminals. Negative 325 would also be the same spot. So all three of those would live at the same spot.
So you can have
Absolutely, yeah. A negative and positive could definitely live at the same spot. Yeah. Probably just write the numbers and identify positions. Probably wouldn't have to draw it yourself. All right, the moment has come for me to introduce to you the unit circle. Ladies and gentlemen, meet the unit circle. Oh, it's so much smaller in real life than it is in pictures. It's really small, isn't it?
Yeah.
Like I pass this out and you think this is some humongous circle, but look how small it actually is. It's called a unit circle because this radius is only actually 1 unit. Okay? So, grab your unit circle. We're going to put a few coordinates on it. What coordinate would live here at 0 degrees? 1, 0. So you're going to put that. If you're confused on where that would go, it would go in that empty set of parentheses. It would be 1, 0. Okay? What? All right, let's go up to 90 degrees. What coordinate would live up at 90 degrees? Good. coordinate would live over at 180 degrees. I mean, it is so much smaller than you expected, isn't it? You have to admit. And then down here, it's smaller than what I picture. It's so little and cute, that little unit circle. All right, now that we've labeled our coordinates at 0, 90, 180, and 270, we're going to go and label all the degrees that we have skipped. So there is a pattern to it. It's not like you'd have to memorize all this. There's definitely a pattern. The pattern is, if it's a large gap, it's a 30-degree gap. And if it's a small gap, it's a 15-degree gap. So you basically add 30, add 15, add 15, add 30. So if we were at 0 here, correct? Let's go ahead and add 30 to that, because this is a large gap. So this should be 30 degrees. You're putting it in that degree slot where there's that little circle. Now you're going to add 15 more, because this is a small gap. 45 degrees. Add 15 more to that, 60. And then we have another large gap, and that's how you get up to that 90 that we have already labeled. Make sense? So that's your pattern. You can just spin the whole way around using that same pattern. Yeah. Oh, we're not going to get to that today. That's another day. So go ahead and you do the pattern. If you get stuck, look up, because I'm going to go ahead and spin around. Add 30, add 15, add 15, add 30, add 30, add 15, add 15, add 30, add 30, add 15, add 15, and add 30. All right. Let pause and let you guys catch up with your circle. So this kind of discuss, I would not write anything down from the slide. I'll save the conversion slide till later to have you write that down. But this just discussed that a radian is another way to measure an angle. A radian is about this large with your angle measurement there. So in degrees, let me just tell you what that would be in degrees. So in degrees, 1 radian is about 57 degrees. So it's very similar to converting from inches to centimeters to convert from radians to degrees. That's what it is. So we'll talk in a few minutes how to convert, but for now we're going to spin one more time around the unit circle. I would use a different color, maybe like a red pen or maybe a blue pen if you were using pencil, so you can distinguish the radians from the degrees. Okay, we're alive. Let's just get our pen out and not talk too much. All right, so starting at our initial side would be 0 radians, of course. If you want me to write a 0, it doesn't matter. I write these just on the inside because that's where we have room. So our first stop is at 30 degrees is pi over 6 radians. All of these have pi's in them. Our next stop at 45 degrees is pi over 4. And if you really want to and you're at home and you're like, my unit circle's messy, I want to print out a clean, fresh one. You just go on Google and Google filled in unit circle. You can print one out that's already filled in. So that's just up to you if you want a nice looking one. Pi over 3 would be 60 degrees and pi over 2 would be 90 degrees. I'll pause, let you catch up. Let's continue on our journey. At 120 degrees, it's 2 pi over 3. Then it's 3 pi over 4. And then it's 5 pi over 6. So there is still a pattern, but these are yucky enough. I'm not going to make you memorize them this year. We'll save that for pre-calc class next year. All right, we're going to continue on our journey. We're at 180. 180 is pi. Radians. 210 degrees is 7 pi over 6. At 225, we're at 5 pi over 4. Then 4 pi over 3. Some of you are seeing that pattern and you just guessed it. Some quadrants have an easy pattern. Some quadrants have a little bit harder of a pattern. At 270, we're at 3 pi over 2. At 300, we're at 5 pi over 3. At 315, it's 7 pi over 4. And at 330, it's 11 pi over 6. And I guess I should probably tell you this, 360 is the same thing as 2 pi. So I'll pause and let everybody catch up their pictures. Oh, right, I just had a student ask, so how could I turn 80 degrees into a radian? Well, guess what? I'm going to tell you right now. I already have this on my formula board. To convert from degrees to radians, you will multiply by pi over 180. And to go then from radians to degrees, you will multiply by 180 over pi. So one kind of gives your guy a pi, and one kind of cancels your pi out, and you'll see how that works in a minute or two. I'll pause and let you write that down. All right, so let's give two of these a try. We're going to start with our 125 degrees. It is definitely a degree, and we're trying to convert into radians, so we're going to multiply by pi over 180. That would be 125 pi over 180. Now, you have the option to reduce that by hand. You could divide the top and bottom by 5. There might even be a bigger number that divides both of them. 15? Nope, 15 doesn't work. I think 5 is actually the biggest number, so divide the top by 5 and get 25. Divide the bottom by 5 and get 36. And I think that's about as far as you can go. Now, my students are always looking for a way to have the calculator help them cheat a little bit. Calculators can reduce fractions down. Do you remember how to do that? The problem is calculators cannot fractionize pi because pi itself is an irrational number. So if you insist on having the calculator help you, you must only type in, try it with me, 125 divided by 180. Hit math, enter, enter. You'll have to manually, by hand, put the pi there yourself. Because if you try using the pi button in the calculator, you will be unable to fraction the answer. Pi is irrational. Okay? Cool. Let's try going the other way. Let's try starting with radians. So it's negative pi over 12. I think in my last class I lost my puppy and I lost my negative sign of them thinking about this. Oh, no I didn't. No I didn't. I lied. I did it correct. Alright. So we got a negative pi over 12 and we're going, that's a radian, and we're going to degrees. So we're going to put our 180 over pi here. And this always ends up happening. The pi's always end up cross-canceling. So we'll have negative 180 over 12. Let's see what that ends up being. Or you just type it in, negative 15. I mean, yeah, they both would divide by 4. They'd actually both divide by 12. Cool, so that's how you convert from one to the other. You can go around the whole entire unit circle and convert every single one of those. That would be fun if you're bored this weekend. How are we doing on writing things down? We have one last topic to cover. And my students told me they did do this in geometry. Although, I don't know if I believe them if they've never heard of a radian. Maybe they used a formula that used degrees. So the last thing we're going to talk about today, these are the two formulas you're going to want to add on. Arc length and area. All right, I was just discussing with my geometry scholars, because I know a lot of you people are also in geometry. They said they're literally just taking a test over arc length and area right now. And they told me their formulas were slightly different. And the reason your formulas in geometry are different than these is in geometry, your theta goes in as a degree. And in here, your theta is going to go in as a radian. So that's why the formulas are like slightly different. Okay, you all have the formula down? Our last problem is a softball field problem. A softball field is forming a sector, basically like a giant piece of pizza. So we're finding the area of a piece of pizza. With the dimensions shown, find the length of the outfield fence, so that'd be that yellow guy, and find the area of the field. That'd be the green and brown part. So the first problem I'm seeing is our theta right now is 90 degrees. That is not in radians. If we want to be able to use our formulas of the day, we need it to be in radians. So what is 90 in radians? Look on your unit circle. Pi over 2. So pi over 2 is going to be my theta. What's going to be my r value, my radius of my circle? 180. So let's go ahead and do our arc length formula first. So the arc length formula you just jotted down was the arc length S equals r times theta. So the radius is 180. The theta is pi over 2. You can go ahead and type in that and use the pi button and get a decimal. That's fine because this is the length of a fence. Decimals are okay for lengths of fences. 282.74. That's feet. So any issues on arc length? Yes. Alright, and to finish off our day, sector area. So sector area formula is 1/2 times r squared times theta. It's going to be a really big number because we're going to be squaring 180 and then timesing it by pi over 2. So let me type this in. If I remember right, it's like in the 20,000 range. Alright, ready for this large answer? 25,446.9. Now that's an area, so how do you label it? Feet squared. So I'll let you finish writing that down. The homework you should already have. It's like the bottom section of last night's. Thanks for watching along with the video and hope you guys have a happy weekend.
Did we